Hey folks, today I'm going to talk about why we take the time to modularize our application. It can be quite an investment of time, and quite honestly, it's a little bit of a different paradigm than perhaps we're used to thinking. So why would we take the time to do that? I'm going to give you 4 reasons today why I think it's a worthwhile investment. Let's get started. Every once in a while, whenever we're building our application, it seems like I make an arbitrary decision to all of a sudden just make a new module. So say you're working on feature X, I might say, you know what, hit pause, don't start developing that feature yet. How about we take the time to build out a new module? And every once in a while I'll get a little bit of pushback, which is totally understandable. People want to know, why would we take the time to do that? Usually people just say, well, I could just get started on this feature right away if I simply just made another package, threw everything for the feature inside of there, and called it a day. Wouldn't that be the same thing at the end of the day? Well, not really. So let's jump into the first reason why I advise that we build modules for these kinds of things. So for that first reason, builds are always going to be faster when you can modularize it. And by always, I mean in a majority of cases. This is one of the reasons why Google and the Java community as a whole has taken the time to implement this feature into the Gradle build system. It's an excellent feature that you can really see at work, especially whenever you're running this in a command line. So if you ever used a Gradle wrapper and you say, build my project or build my app, a lot of times you're going to see a bunch of threads spawn up. Sometimes they'll sit idle, but every once in a while you'll see a whole bunch of activity flicker across the screen. That's because you have multiple workers that are taking the time to build that part of the application in parallel. And for those of you who have done threading and multi-threading in the past, I really don't have to tout the benefits of doing things in parallel. It's like if you have a bunch of water in a tank and you want to shove it through one pipe, well, if you had 2 or 3 of the same size, obviously you'd get the job done a lot faster. Same exact idea here. If you don't ever use Gradle in the command line to build your project, let's say you use IntelliJ or Android Studio, when you build the application and that little build panel pops up, there's little spinners down there that you'll see. Sometimes you'll see just one spinner doing work. Other times you'll see multiple spinners doing work. That means you have multiple Gradle threads that are running the build in parallel. Another way that you can take a look at this is if you already have a modularized application, like what we do, you'll see sometimes in the build log, you'll see certain references to, say, our app module. Then you'll see references to another module, say module 1, then module 2, then maybe it'll refer to module 1 again, and then app. And you'll see all these interleaving names. That's because all of those steps are being run in whatever order it deems necessary, but they're all being done in parallel. That's an excellent way to see Gradle doing its best job here at work. On to idea number 2. This one's a little bit more of an engineering best practice, and I like to think of it as simply it's a separation of concerns. So typically when we think about these things, we'll say separation of concerns, say maybe at the class level or at the function level. You don't want anything going on, too many things going on in one particular piece of code. Well, you can think of this as being more of a macro level concept. You don't want any particular part of your application having too many responsibilities. It allows you to focus on just having a single feature and delivering that just within the scope itself. And here's one reason why this is a great idea. A lot of times if we're building a feature, and let's say we need a button or we need a style or just something that's involved that we built for another part of our application, if we're all inside the same module, it can be easy just to say, oh, well, I'll just go grab that and I'll just incorporate it right in. Well, that will work, but honestly, there's no real separation of concerns here. So you have all these different concepts that you're putting together, and it kind of makes for some form of spaghetti code. It may not be obvious because it's not necessarily code that you're writing out, but if you zoom out and you kind of look at your entire code like maybe a graph or something like that, you'd see all this stuff is going on that you didn't really intend to because you don't have a streamlined setup for it. And that's one reason that modules can really help you focus on just one thing. So it forces you into better practices because you have to really think about how you're constructing your project and your code from a big level instead of just at the class or the function level, which are the more micro levels. If we were to think about this in another example, you know how microservices are kind of all the buzzword these days. Historically, whenever you had, say, a web application that you were building, you would build the web application as one single jar file, one single project, and then you would ship it onto a server, and it would just be this monolithic application that's always running. So whether you needed to use feature A, B, or C, you're going to be loading the entire application because, well, that entire feature needed to be there because it's running inside of a monolith. However, if you use a microservice, you only need to use the resources on a particular microservice that are applicable to what you're using right now. Same idea, just think of it as a mobile application instead of a web application. The third reason I'm going to share with you is actually another reason that Google touts their modularity of their applications. It's because each module can provide different abilities. And I'm not talking about the code that you put inside of the module, I'm talking about what the module has to offer for itself. So inside of Android, every module is based on some sort of Gradle plugin, whether it's an application or a library, but there are other ones. Other ones that provide very unique abilities that only are available if you modularize your application. The first one being dynamic delivery. And the way this works is, let's say that you have an application that's broken up ideally, so they're all modularized the way that you'd like. And let's say you have a login page, so you go to the login page, but if you never get past that login page, say you didn't like the app and you uninstall, no worries. Everything else after that, you never needed to download because you never used it. But let's say you get past the login, and now you want to get to, say, the main account portal. Let's say that that's its own module. Well, after login, you can download that extra module from the Play Store and it will be available on your phone. So that means your phone is only storing as much information as it needs just for what you've used it for. And as you continue to explore further parts of the application, those modules will continue to download and stay on your phone. That's the idea of dynamic delivery, and again, that's only available with a module. Instant App is another great idea. So for example, if you have an Instant App, all you need to do is say send somebody an email or a link, an email with a link inside of it. And if they click the link, if that app is Instant App enabled, they don't even have to install your app. It will simply provide a quick download of maybe 4 megabytes, a simple lightweight application. Your app will launch, and then as before, you can continue to explore and download different parts of the application as it continues to unfold in front of you. Again, this is something that's only available with modularized applications because everything's broken down into small bits. The fourth reason why I push for modularization of our application is more from a best practices perspective. When you have strongly segmented code where each feature stands alone, you can think of it as a place that allows you to experiment a little bit. So let's say that you wanted to use a newer version of a library, or you wanted to upgrade something. Well, instead of affecting every single part of your application, you can focus on just this particular feature. So that allows you to build, say, more modern applications, vet it inside of a particular module before you release it to the rest of the application and say, yes, this is definitely the way we want to go. So you can think of this as some way allowing you to create what I like to call model city code. So whenever you have model city, that's typically a place that you look to as inspiration for the rest of your code. So again, that strong segmentation allows you to think about things differently than if everything was just kind of thrown into the heap altogether. Now, this is something that many companies are doing, and one in particular is Robinhood. They put out an article not very long ago talking about how their application, they took the time to break it up from a monolith down into, if I remember the number correctly, it's about 20 plus modules, and that may have changed for now. But really, it gives you the idea of the granularity that people are thinking about when it comes to their applications. This is definitely the industry standard. This is the trend that they're going, and it's really, you don't want to be left behind with it. So in this video, I've given you the why. Why do we take the time to modularize our application? And why in many cases, not only do I think it's worth it, but so does the industry as a whole. Next video, I'm going to start talking about that dividing line. So what is the point in whenever I say it's no longer worth putting this inside of an existing module or inside of our main app module? We need to invest the time to break this up. And that's what we'll cover next week.